And without further ado, I'd like to introduce our presenter today. Blake Spencer is a local account manager and regulator specialist operating out of Salt Lake City. Since joining SwageLock in 2002, Blake has had the opportunity to work with customers in the oil and gas, chemical, petrochemical, mining, and aerospace industries, among others, helping find solutions to challenges both big and small. Along with pressure regulation, Blake's expertise includes steam and compressed gas applications. Blake is passionate about helping customers find the right regulator for their application, ensuring reliable and safe system operation. And with that, I'll turn the time over to Blake. Blake?
Hey, thank you very much, Easton. I hope everyone can hear me okay. We're going to be talking a little bit more in our second section of the regulators, a little bit more about applications and some potential places that we want to be able to use the regulators. Now, last week we talked about pressure reducing regulators, some of the features and benefits, the size, material, how they function. And before we go on, we need to remember that pressure regulators reduce the supply or pressure to a lower outlet pressure, to maintain the outlet pressure despite fluctuations that our system may have in our inlet pressure. Now, the reduction of this inlet pressure to a lower outlet pressure is key characteristics of all pressure reducers or pressure reducing regulators. Now, of course, we need to remember when we're choosing or selecting a regulator, we must consider all the factors, such things as operating pressure, ranges of the inlet and outlet, the flow requirements, and of course the fluid. Is it a gas, liquid, toxic? Now, we need to look at the operating temperature range, and of course the material selection of the regulator, making sure that it will perform as we have desired. Okay, so now we looked at this slide last time. I've got my pressure regulators on the inlet side. Any pressure we have that we want to control is going to go through our pressure regulator. We'll talk a little bit about flow today here as well. So we're going to be talking about back pressure regulators. That is on the right side of the screen. We're going to talk a little bit more about those in a couple more screens. But just to reiterate, the function of the pressure regulators to maintain a constant outlet pressure independent of flow and varying inlet pressure. I just talked about that. Now we have the back pressure. We talked about that briefly. Now the function, I'm just reading here off the screen, the function of the back pressure regulator is to keep an inlet pressure constant and is to control this pressure even with varying flow. And we're going to talk about when we would want to use a back pressure regulator. Now, we talked about this before, and I just want to make sure that we understand we have spring-loaded, dome loading, differential pressure is the next one, but then we have pneumatic loading. Someone were to ask me, say, Blake, how can I recognize what type of a regulator is in my application? Well, sometimes that can be difficult, but simple looking at these pictures, we could say, well, if something has a plastic handle on the top of it, it's typically going to have a spring mechanism inside of it. You can see how the neck is a little bit longer, skinnier than the body. I would say it would be a spring loaded. Now, if I go over one more to the dome loading, if I looked at that regulator in my application, I would say that will probably be a dome loaded or using air as my sensing mechanism in there. So sometimes by looking at it, you can guess and see what type of regulator you are using. Okay, now, last week we talked a little bit about the flow curve. We definitely need to understand what the best operating range would be. It's going to be key. We have our pressure on the left going up, flow on the right, on the bottom. Then we have the pressure being set in a regulator, but then we also need to be looking at the flow range. We're going to talk here shortly about that. Okay, now we had talked earlier about two different types of regulators. We have a single stage and a two stage. Okay, so now let's take a look at some of the applications where we would want to put a single stage regulator. Now, we need to understand the supply pressure effect on regulators. Of course, you're going to have a high inlet pressure equals a high flow. Typically on your application, you would want to have, if you've got a high pressure, you would want to use a piston style regulator. There's, as I mentioned before, a diaphragm style as well as a piston. Diaphragm handles low pressure. Piston typically handles higher pressure. We're talking 1,000 psi to 10,000 psi for the piston style. Now, if I scroll down here, it says the inlet pressure drops, the outlet pressure goes up. So in your system, if you have a constant pressure, you put a single stage regulator, you might be fine. That is if your inlet pressure does not fluctuate very much or very rapidly over a certain period of time. Sometimes you'll see this if you set your regulator for, let's say 25 psi, you leave for a week, you come back, now it's at 30 psi. You're like, well, why has it gone up? Well, I look at my pressure on the inlet and it has gone down. So there's some different things in our applications. How would I reduce this effect? In the very bottom, I can show you can use a balanced valve or a balanced regulator or a two-stage regulator. So we're going to be looking at some of those here in a second. Now, if your regulator creeps, let's say in your application, you have put in a regulator and over time the pressure increases. Next week, we're going to be talking about how to prevent this, but these are some of the key characteristics that one should be looking at their regulator, making sure that it is the correct one. Now, sometimes you may put in the correct regulator, but because of internal damage, internal leakage, potential stuff, dirt gets into your regulator, it may cause that creeping effect. But that is something that you need to be always looking at your system, potentially putting in a relief valve to protect what you're trying to regulate or the machines that you're trying to regulate. Now we're going to talk a little bit about the flow control range. Now on the left screen, I can see that we have a flow coefficient of 0.06. If I look in the screen to the right, flow coefficient of 0.20. Now someone would say, well, the normal flow coefficient on a valve would be 0.06, therefore 0.06 gallons per minute at 1 psi, but not the case in a regulator. If I'm looking at the left side of the screen here, you can see the outlet pressure on the left, 0, like 5, 10, 15 psi, and then the nitrogen flow on the bottom, I've got 2 cubic feet per minute, 4 and 6. If I look at the blue line, that represents a single stage regulator with a 0 to 10 psi range. Therefore, if I was to put in that regulator in my setup, I look at the blue line and I would see the hysteresis on the left of the blue line, right by the outlet pressure, how it goes down abruptly, sharply downward. That's the lockup zone. Then, as you can see, as it travels downward, the hysteresis travels downward. Therefore, I could say, well, at 5 psi, I go over and see where the white line crosses the little blue line, and then it dropped down, and that's about 3 standard cubic feet per minute. So this particular regulator, whatever regulator, with that flow coefficient, that's the maximum amount of flow that you will get out at 5 psi. There's no ifs, ands, or buts. You really have to go off of the flow charts. Now, if I want a little bit more flow, I could jump to the other side and look my flow coefficient with 0.20, a little bit more flow. But you need to figure that out before you put in any regulator into your system. Very, very vital for your application to be running smoothly or working properly. Now, I have a picture here of a single stage regulator. I basically are saying I'm coming in and my desired range is I want to set it at a certain amount. I'm not really worried about if its pressure's going up and down. I just want to make sure that it knocks it down. Typically, I call this a point of use regulator. If you had a nitrogen bottle, you put on a single stage regulator, you wanted just to regulate the pressure from 3,000 down to 50 to blow off equipment. You really don't care about the flow. You don't care about the maximum and flow or minimum flow. You just care about the pressure going down. So that's why I refer to as a single stage, a point of use regulator. Now, I've talked a little bit about putting regulators onto bottles. Now, we all have seen a regulator. They're with a little small piece about 2 inches long with like a nut and a nipple, then going on to the cylinder bottle. It's going to be put on with a CGA fitting, a compressed gas association, basically fitting. Every gas bottle has a certain CGA number associated with it. So therefore, you find the gas, you find the right regulator, therefore you can use that CGA onto that regulator onto that bottle. Okay, so that's very key in sometimes our applications. Now you can see here a nice cylinder with you can see the top there with the handle of the cylinder bottle. Just to the left, that's the CGA fitting inserted into my two-stage regulator. We'll say, how can I recognize a two-stage regulator? Typically, it's a little bit longer than a single stage, and you can see the green handle on the front, but then at the back end, you kind of see another, like a little dome shape. That's representation of a two-stage regulator. Therefore, when the bottle decreases in pressure, the outlet pressure will not be increasing. It will stay constant because there's two regulators in here. Therefore, they will suppress the inlet supply effect onto gas or for your system on your application. Okay, so now we're going to take a look at, now what happens if I have a bottle, let's say 2 bottles, supplying a system, and I do not want to let the pressure to ever decrease or the supply to ever to run out. I would set up 1 bottle, 1 regulator. As soon as it's done, then an operator would need to come in, change out that bottle to a new one. Well, therefore, there's a little bit of downtime. Well, in the industry, we call it a changeover regulator. You can see here on the left what it looks like, but on the right, I can put 2 bottles hooked up independent of each other simultaneously at the same time into that bottom regulator. That regulator will sense the amount of pressure that is in each bottle. So it's taking the pressure from supply 1, knocking it down to 500, then sending it up to the top regulator, which drops it down to, let's say, 100. But now once supply pressure, cylinder 1 is depleted, it automatically switches over to cylinder number 2. So just another thing for your application on how to use different types of regulators. Now, we're going to go a little bit here into back pressure applications. Now we see the tank here, we see the back pressure regulator, and it's going to control the process or the pressure from the process side. If I had a tank and I wanted to keep the pressure in there of 50 psi, I would put a back pressure regulator on there. If the pressure in the system went or rose to 55 psi because of temperature changes, it would let out 5 psi out of that regulator, therefore dropping the pressure in my process or my tank down to 50 psi. Very finite way to control a pressure within a tank. For example, sometimes a lot of people will use tank blanketing applications. So the process applies on tank blanketing applies to gas to an empty space, like in a storage container. So the term storage container here refers to any container that is used to store product, regardless of its size. Now, although tank blanketing is used for a variety of reasons, it typically involves using a buffer gas to protect the products inside the storage container. A few of the benefits of the blanketing include a longer life of the product in the container, reduced hazards, as well as longer equipment life to the number of cycles. So I can see here I have a tank with fluid going in. Let's say there's water, and I put a blanketing material in there, nitrogen. Well, the amount of water or fluid decreases, I would need to have more nitrogen going in there. But if the level of the water increased, then less nitrogen is needed, so then it would go out of the back pressure regulator. So you can see here on the yellow, atmospheric pressure going in, and then on the green, it says fluid in, that's a liquid, and the fluid out would be the liquid. So if I wanted to maintain the void within that container so it would not rust, I would want to put in nitrogen to blanket the volume in there. But if it needs to increase or decrease pressure, I would then use a back pressure regulator. So here's an example of what one would look like typically. You'll see this on most every type of a cylinder or container that's out there, because the pressure inside is going to fluctuate with input, potential temperature changes. So in order to make sure that that is not becoming a bomb, we need to make sure that we have good sensing diaphragm type regulators on the inlet, as well as a good sensing diaphragm back pressure on the outlet. Now I've gone over a few different items here on the pressure reducing and a little bit of sizing. Sizing is a kind of something that every manufacturer should be able to do for your application when you are trying to size a regulator. So with that, I just got to stop here for just a couple questions. I try to go about 30 minutes, so we're going to stop for if anyone might have a question. So Mark, do you have anything for me? Or Easton?
Blake, we have, hold on just a minute.
Okay.
It says right here, we have a question from someone. It says, I have a 1-inch line and I'm looking at one of your dome loaded regulators. Okay. What's the max capacity I can get out of a 1-inch regulator? And it goes on. So that's what I had.
Oh, okay. Okay. So that's okay. So I'm going to cover that here just in a second, but I can see his point. Sometimes someone will say, well, Blake, you keep talking about pressure, but I have a certain amount of flow that I need, but I only have a certain size. So this particular question is, this gentleman or lady has a 1-inch application saying, I need to get the maximum amount of flow. So I need a full volume of flow coming out of that regulator for my process. On a regulator, we can size the internal components of a regulator and say this is what the average would be. Depending on the C sub V, we can either lower the C sub V or increase the C sub V inside of that regulator. By increasing the C sub V inside of a regulator, I can actually obtain more flow out of a certain sized regulator. So I might be able to, on a 1-inch size, I might get an 1.25 inch amount of flow out. But if I only had that size and I wanted a less amount, I would reduce the C sub V to a smaller C sub V. Therefore, it would reduce the amount of flow coming out of that. I will not be able to adjust it on the fly but I will be able to adjust it when I put in the regulator.
Okay.
I hope that helps out there, Mark, or the
Okay.
question that was asked.
We have one more, Blake. It says, are the crossover regulators factory set to a specific pressure to change from cylinders? And I'll publish that one where we can all see it.
Okay. Okay, so some manufacturers will preset a regulator to your specific requirement, but 90% of the time they would come unset. Therefore, just spinning it left or right, depending on what you're trying to obtain, you would be able to easily set a regulator in the field. But like I was saying, if you needed a dome loader regulator specifically set, you can get those preset by the manufacturer. But a lot of times, by simple turning the knob left or right, you're going to be just fine.
Okay. We have one more.
Okay.
It says, I have several single stage regulators on my 2200 psi gas cylinders.
Okay.
My gauges read 4000 psi on the inlet and 600 psi on the outlet.
Okay.
Says we set our regulators at about 25 to 30 psi, which meets the requirements of the equipment.
Okay. The
question is, should I be using a two-stage regulator on my cylinders for more finite control? And he says that they don't have a regulator on the equipment, so it's coming off the bottle then, or the supply source.
Yeah. So answer that quickly. You will not get very, very accurate pressure control with a single stage coming off of a cylinder. It's more recommended to use a two-stage. You can use a single stage, but it may raise a couple PSI during the day. You readjust it, it may go down, but then a couple hours later, it's gonna be going up. And you should have a little bit smaller gauge on there so you can read a little bit more finite pressure requirements.
Okay, so that's an option, Blake, or I'm going to kind of lead the witness on the second one. His next question is, should I have two regulators? So that's the other option, right, Blake? You have one on the cylinder and one at point of need at the equipment.
Yeah, two-stage regulator or two single-stage, one off the bottle, one right before the machine. I've done that many, many, many times to make it more accurate because some of our equipment's pretty sensitive.
Okay, I have one more question before we go back to the presentation.
Okay.
It's the first one is kind of a statement question. It said, "Isn't your back pressure regulator just a pressure relief valve?" And then it goes on to say, "Isn't your back pressure regulator?" Yeah, well, that's it. It's listed twice, the question.
Okay, so that's correct. A very controlled relief valve, you could use a back pressure regulator. If in your system, if you have some fluctuation of pressure and you want to relieve it, you've got a couple choices. A relief valve, now sometimes a relief valve is a safety valve, and there's two different categories of a safety relief valve and a back pressure regulator, okay? But they're going to be doing the same items. One thing about a back pressure regulator is, if you have a pressure of 100 psi in your system and it goes 105 psi, that back pressure is going to take out that 5 psi in a second and then reduce it down to 100. But with a relief valve, it goes to 105. It may drop it down to 60 before it reseats itself, and then jumps back up to 100 psi, back to your main operating pressure. But a back pressure regulator is and can be used as a relief valve to control pressure in your system.
That's it for questions, Blake.
Yeah.
Thanks.
All right, great. Hey, thanks, guys. So I try to keep it about 30 minutes. May go a little bit longer here, but let's talk a little bit about process regulators. Now, when I'm talking about process with large flow, I want a good finite control. Typically, I'll use this in food applications. For example, I've had a customer that they've said, I need a constant stream of food or their mixture. Then therefore, I need it to flow at a constant rate, constant flow at a constant duration through this 2-inch line. Therefore, I need a regulator that will make it go exactly the speed I want it to, because at certain intervals I need to inject other ingredients. Therefore, the final product will be satisfactory to its customers. So that's when we need to look at maybe a larger flow regulator with more control to it. Now, when I talk about control, that's when I jump in here into my dome loaded regulators. So common, I can put air in the top. The one on the left, I have a pilot regulator that will control the flow, will control the set pressure inside of the dome on the upper portion of it. And you can see how on this particular dome load regulator, that's a 2-inch line there, but I'm only controlling it with a low 1/4-inch regulator in controlling the pressure. So the set pressure will be controlled for a large flow of material that I'm going through there. Now, we don't always need to set it by hand. We have electric controlled, operated, dome loaded regulators. So this will control electronically the amount of pressure that's going into the top of the dome. So you could be remotely, you could have this in a controlled area. You could have it in a food processing area, and someone could be sitting back with a PLC and say, in 5 minutes, I want it to be at 10 PSI. In 32 minutes, I want it back down to 7 PSI. So this can be controlled electronically. So therefore, your process will be controlled a lot more finite and potentially even remotely and a little bit more accurate. So the electronic pilot controlled regulators or just like a regular pilot controlled regulator can really affect the performance of the dome loaded regulators in application. Now, here's another hysteresis graph we need to look at. You know, I've talked about the flow curves. Now let's take a look at the red line. I mentioned here the dome loaded are very, very accurate. The dome loaded with external feedback is even more accurate, and I'll demonstrate it here. On the graph, we can see the red line. That's the hysteresis of a set spring with a spring loaded. We can see the initial, there's like initial lockup saying, I just can't flow out of this regulator until I get into my desired zone. But as you can see how it drops off. If I go to the blue line, that's a dome loaded with a pilot regulator on it. You can see it still drops off eventually. But now my dome with external feedback, that is giving us a flat line. Now someone's like, well, I don't care about a flat line. But what that is telling us in a process, I need to make sure that my pressure, my flow is very, very constant. I cannot have any drooping in my flow characteristics because my application dictates that I want to have a very flat curve. Now, we have seen what a dome loader regulator looks like with a pressure reducing regulator on it or electric one. Now, this is a little representation of what does it mean with an external feedback. You can see on the red, we'll call that the inlet pressure. The dome loader regulator is there in the middle. We can see the small pilot regulator on the top left. It's coming in at red, going out at green, setting the dome loader pressure. Then it's going out of the dome loaded regulator at a certain set pressure. Now, with external feedback, we go 6 inches below that. We have an external port that goes back into the dome loader regulator. Then it's saying, hey, I am reducing at 10 PSI, but it's 11 PSI. Why is that? So it just kicks back in and automatically changes itself so it reduces back down to that 10 PSI. This is when you have applications where you need to be very, very controlled in what you are trying to do. Now, here's an example of what one looks like. It's a little tough to see the external feedback on this, but this is a plant that they're saying we need to have control of our gas. We need to have, because you can see in the background some dewars and some different pieces of equipment. They're like, in our burners, we need this exact amount of flow. in this storage tank, we need this amount of flow, no matter what the inlet no matter what the inlet pressure is going to be. If it fluctuates at all, I cannot have any fluctuations. I need to have it exactly. So you can see some of these regulators can be fairly large in different applications. Now, sometimes you'd say, well, Blake, I need a diaphragm, or I need a regulator that's very, very sensitive. I've got a large flow, 1 inch up to 2 inch, up to even 6 inch. And I want to control 0.01 psi, okay? So therefore, you can see on this picture how my diaphragm on the top is large. Sometimes these diaphragms can be up to 12 inch. I've seen them as big as 24 inch. And therefore, the control mechanism in there is very, very controlled, such that your inlet pressure can be really whatever, but your outlet pressure, you can control it very, very finite. A lot of times, these are in medical equipment, pharmaceutical applications, gas industries. Actually, on your lawnmower in your car, you see the diaphragm regulators, because no matter how much gas you have in your tank, you want to have a certain and a constant flow into your engine or your carburetor or whatever application that you might have. Okay, so sometimes you see a lot of these on gas plants, because when you have gas coming in at low flow, like we're talking at, it's coming in at 1 psi, I need to regulate it to 0.5 psi. That's when you would want to use a large diaphragm. Now, here's another application. When you have a pump or an injection pump, you need to maintain the pressure on that seal, as we call it here, the mechanical seal supports. Because if you do not have a pressure set on a seal, then it's not going to, the rubber may not hold its place. Now, it will hold its place by the housing that it's in, but sometimes you need extra support by like a blanketing with nitrogen in there, or like I said, the mechanical seal support. So you can see here, now if I wanted to recognize what this regulator would be, it has a little green, a red handle on it. I'd say, oh, that's probably a spring-loaded type of a regulator in there that I can adjust manually. Okay, so you can see the different end connections that might be available or that might be needed. So a lot of different manufacturers are going to have a lot of different types of connections, and we talked about those before. Now, if I look at this one right here, this picture, there's a lot of CNG around the country, there's a lot of gas applications, but you can see there's a red handle, there's a blue handle, different types of regulators within a system. I want to control the pressure coming in, I want to control the pressure that's going out. So we need to have gauges, we need to have regulators, we need to have certain sizing. We'll talk about next week about how to set up some of these setups or regulators in different applications. Now, as I come here, I look and say, wow, that's just a lot of stuff. So a lot of hydrogen reducing panels that I have seen and actually worked on, we're going to be reducing the pressure to high to low, sometimes low to high, depending on what we need. But we can see here we have an intricate amount of regulators. Some are going to be pistons, some are going to be diaphragm, as I mentioned here. But if I was to take a look at that, sometimes I'm in awe about how much or how many applications regulators can be used in. So if I don't have a regulator, I may damage some equipment down below. And I'm going to be talking about that next week, where how do I protect myself? How do I protect my equipment from these regulators? Can they fail? When do I need to change out a regulator? Sometimes people will put in a regulator and think that it's good forever, but we need to understand that there's many factors determining what type of regulator that we're to be put in. Then we need to determine how are we going to maintain that regulator within our system? And that's what I'm going to be talking about next week. So I hope everyone can join. I'm going to take a couple questions here, right there, my break for questions. So If anyone has something that I missed or I haven't quite covered, then let us know, let Mark know, and Mark, I'll just let you have the mic. Or maybe Easton have the mic.
All right. So, Blake, we have a couple. Hold on, man. We have a question. It says, what model is the dome-loaded regulator we are seeing?
Oh,
It says, struggle on spec sheet to find tube stub connection ends.
okay. Okay. So, in our industry, or within the company that I'm working for, within the Swagelok company, dome loader regulators and the RHPS, and it typically will have a D in the part number, D for dome loader regulator. Now, there are, in any catalog within a company, you would look at it and say, well, these are the different options. If I was to pull up the catalog for dome loader regulators, I would see typically what is available, NPT, flange. If there was a product that I was not seeing, that's when you want to just give me a call or just email me and say, hey, Blake, I need tube adapters on this particular model. Can you do it? Then I'd call the factory and say, hey, this is what I need. This is what I'm looking for. Can it be done? And then they're going to say yes or no. Then I would be able to help you or whomever's looking for it, direct you into the best product for application. You know, I'm not going to just try to sell you with whatever will work. I'm going to take your application, make sure that we get the right product on there. So to answer that question is, we need to be looking at specific catalogs, looking at the exact part number, making sure we have the right size, and I can help size up the regulator, how much flow we needed with my calculators that I have. We look at the temperature and material. Therefore, I'd be able to help out, get specifically what you might need. And so that's with any application. I really try to take a look at what's needed. Therefore, I can specify a regulator that would work.